Welcome to part 3 of the Shadow Tables tutorial. This is about putting it all together. So let's have a look at the associations screen in this database. And this is sort of a normal screen template that I use with a list at the top. We've got the Save, Cancel, New, Delete buttons. This is like a CRUD thing. CRUD being Create, Read, Update, Delete. Now let's have a look behind the scenes here. And you'll see that this subform is bound to the body shadow table. You can tell by the underscore at the end there. So we've just bound this as if we were editing it normally, because we pretty much are. And so when we click on a list item and the after update procedure runs, we've got a little bit of code here which is loading. It's using the shadow table object. It's running a load on the association ID that is in the list. Let's just have a bit of a look at how we need to set this form up. So there's an association shadow object here. This is a table shadow object, and this is the child. So we have related membership records, and that is set up as an object as well. So each of these basically manages the validation, editing and deletion and so forth of the shadow table. You can see here in the form load it does an init shadow table objects, which I've sort of put in a separate section down the bottom. And this is the code that initializes everything. So really it's just creating an object and then telling it the table it needs to use. We can put a table description in, which it can use in error messages. We can pass it a different schema from the default table schema, but by default it'll just look up the schema for this. So that means all the metadata, the data about the fields, types and nullability and so forth. It'll just look up the default ones, the one associated with the body table in the database. But if we want to, we can pass it a different schema. This is an array of control names. So when it validates a form, it may find a problem with a particular control, and it will want to know how to notify the user about that particular problem. So for example here, we've got the body alias control, which is a text box, and that's got a label associated with it. So what this function here does is just go through the entire page and finds all the controls and reads the captions out of their associated labels. And that provides a pretty good way of getting a description for the control. Here we're setting up the membership shadow object, which is a child of the association object. So again, we're passing it the table name. This time we're giving it a description, and the parent shadow. We've run an it child on this one rather than an it, so this time we're passing it the parent object, which is this one. And then we've got to put in a col link list. So this is basically telling it what the parent and child columns relating these two tables are. We can have more than one column. Here the body FKID is the child column, and then we've actually used a generic as one of the properties of the shadow object is the table primary key column name. So we've just used that for the parent. That makes the code a little bit more generic. And we've called the same thing on the subform form to get the page control descriptions. So that really is all you need to do to set it up. Then, as we saw, we can go down here and association shadow.load. It's asking for a primary key value, and basically it will read a value from the database main table into the shadow table. So then all we need to do is we do a bit of logic here, requerying various forms and controls, and a bit of status control on the page. We've got a show and reset related here, so this is kind of just clearing all of the associated information so that we don't have any old values selected when we select a new record. And then we've got other code here. You can see here, here's a case where we're doing a little bit of extra validation. So in this case, we're assigning members to an association, and we can't have more than one person in the same role. So one person can have multiple roles, but for example, two people can't be president, even though one person may be president and treasurer. So we're just calling this function here, which does a little bit of, let's go have a quick look. It scans just to make sure that it's probably scanning the shadow tables, since that's where the data is at present. And then it prints a message and returns and just tells us whether we can go ahead or not. So if we've got a problem, we exit the sub. Otherwise, we'll continue on with the save data function. And you can see here, save data. We've got this validate rex function, and that really, again, that's similar to what we just saw. It goes through, checks all the data values to make sure that they're going to be compatible with the backend schema, make sure that required values are there and so forth. If they're not, it'll make a message, it'll print a message out for us, warning the user and telling them what they need to do to fix the problem. And then it'll return false, so we can bail if we need to. These three lines here are to do with optimistic concurrency, which is just a way of seeing if the data has changed since it was last read. This is the scenario where, say, you read a record, then someone else reads it and changes it before you write the data back, and there's a situation where you could overwrite the other person's changes. So there's a few ways of handling that, and one of them is called optimistic concurrency, and these lines handle that, but a lot of people just don't worry about it, so they're optional. And then we go right down to the shadow save function, which saves everything. Once we've done the validation, then we know it's safe to save this data to the back end, and that's exactly what that does. So it's pretty much that simple. One thing to notice is that because we've added this child here, the parent object realizes that there is a child, so the association saves all the members as well. That saves all of the child data from the shadow tables to the main database. It'll save the entire structure. It'll save multiple child objects if that's what we've set up. So it really does make it quite easy. And although you might think it's easier to do it codelessly, I can guarantee you that once you've had to do any kind of customized validation or anything that's slightly out of the ordinary, even in a very minor way, the automated saves become a huge pain, and we're much better off doing it like this. It's only a small amount of code, but in return for that, we gain an enormous amount of control over the way that the data is stored. Let's just have another quick look here at the attempt save function. This is an interesting one that gets used quite a lot. So this is when we're basically trying to bail out of the form or the record. We're doing that check again that we saw before. And then we've got a query save dirty data function. What that does is it checks to see if the data is dirty, in other words, has it been edited in the shadow table? Because the shadow table object actually caches a copy of all the shadow table data in memory when it first reads it from the database. It reads another data list object out of the database and compares that to the one it had from before, and it's able to tell us if the data's dirty. If it is, then it will print a message and say, do you want to quit out of this, or do you want to save the data, or shall we cancel and just not do anything for now? And then the result can be interpreted to either allow us to continue with what we're doing, or we can require it to bail out. So again, this returns a Boolean telling us whether we're allowed to continue with what we were trying to do. You can check out what these buttons do. It's more of the same really. When we create a new record, we're attempting the save. So if the data that exists is dirty, we're just checking to see if we want to save that or discard it. And then association shadow.new item creates us a new record. All of the buttons work more or less in the same way. One other thing I should cover is, let's have a look at the cancel button. So here again, it's just saying, is the record dirty? If so, then you'll lose any modifications. If we decide that we don't care, we do want to lose the modifications, it's doing this check val reset function. I said earlier how it caches a data list with the original values. It basically resets that so that At that point, it will not consider the record set dirty anymore. And then when it goes to this after update function, that's exactly what happens when we just click on a new record. So this is a way of just ensuring that it doesn't think that the record's dirty, and it will replace it without any warnings. So I just wanted to illustrate making changes to the shadow tables during the save process. So here we've got CMD parent save click. It's a click handler for the save button that calls update tasks, and update tasks makes some changes to using SQL to the shadow table values. And that's before it even hits the validation phase of the save routine. So I'd just caution you, if you are going to try to change values, it's not a good idea to change them in the form. You probably noticed in the examples we've had that the detail form, even for the parent, is actually in a subform of the main form. And one of the consequences of that is that when you hit the buttons, it leaves the subform and automatically saves the record. There's certain things that trigger the saving of the record in Access. Now, if we go altering the information after that save, then Access often interprets that as a concurrency conflict, and it thinks someone else has changed the record somewhere, and it'll bring up that message that says another user has changed the record, do you wish to proceed, etc. So we've got to be careful of that. That's one of the built-in Access things that can cause us problems. And if your save button is in the same form as your detail record, you'll probably need to programmatically save that data before you proceed with the save function. So that pretty much wraps up the shadow tables tutorial. There's a few places you can go from here. One is to have a look at the shadow table reference on the website. Another one is that you can download the shadow table tutorial document off the site and go through that. And a third option is you can have a look at the sample database, which has some of these shadow table pages in it. You can set debug in that and step through the functions.